Welcome to Robotics and Automation News webinars, where you can be part of a global event without leaving your home or office. Attend our live webinars and communicate directly with influential professionals in your industry.
Hello, my name is Abdul Montakim. I'm editor of Robotics and Automation News.com. I'm with Ronnie Vuine today. Ronnie is CEO of Micropsi Industries. And he is going to make a presentation explaining what the company does, and then I'll ask him a few questions at the end. Basically, the company is a software company which has developed a system for the positioning of industrial robotic arms so that it can perform tasks like insert Ethernet cables into devices. But I'll let Ronnie explain all of it.
Okay.
All right.
So I'm introducing Micropsi Industries and what we do about artificial intelligence for collaborative robots, or industrial robots in general. And the main thing, or the thing to remember, is we're essentially giving industrial robots hand-eye coordination, and I'm now going to explain why we're doing that and how that works. What comes together here from a very high-level market and strategic perspective is these three mega trends or major things that just happened in technology. Let's start with the middle one, which is the emergence of industrial robots that are quite unlike anything that has been done before industrial robotics. Industrial robots used to be big and dangerous and very fast and scary. And now there's a new class of robots that just came out of the development efforts of the robot makers that does away with the cages you used to need to make robots safe. And that essentially you can touch them, you can interact them as you would interact with a telephone or a human or just anything human-sized that you have on the desk, and that's just a non-dangerous object to interact with. So that's just happened. These machines exist now, and they're getting cheaper and cheaper, and they're getting better and better. The second trend is artificial intelligence. By now, everybody knows that. Especially in the field of computer vision, deep neural networks have really completely changed what we can do based on computer vision and that we can do with pixels that come into any machine from a camera. And the third one is the market size. Automation is really back for a number of reasons. The most prominent one is probably that China is changing from essentially selling cheap labor to the world to trying to become a proper developed economy where productivity is a thing, and they're creating a middle class, or the middle class is expanding. And while that's happening, Europe and the US famously thought, okay, that's a chance to get production back into our national economies or economic clusters. So essentially, what we see rolling out right now is like a pretty epic struggle over the next 5-10 years of who gets to produce things. And the three clusters, China or Asia in general, Europe and North America, are essentially competing for the most effective way and efficient way of producing things. And very obviously, automation plays a big role in what's going on there. So when I talk about industrial robots, typically, especially in the context of artificial intelligence and deep neural networks, people just assume, because they know robots from the movies, that robots are inherently very smart things that know how to do things. And that's because most robots people know are from science fiction and are really just people in metal suits. In reality, today, robots in manufacturing perform tasks that are completely understood before the movement starts. So in car manufacturing, which is what the background of this slide shows, you know exactly where the car will be at any given point in time. And then if you want to put a weld line there, or if you want to do some painting, you just move the robot in absolute terms to a place in space, and then you do what you want to do, and then the robot moves back. The next car comes, is precisely in the same location. You make precisely the same movement. So in traditional industrial robotics, problems were solvable with robots when they were fully understood geometrically. There was nothing that varies about it. It always looks the same. It always feels the same. There's really no reason to have any eyes or any brain. You just stupidly make the same movements all over again. And it's sort of enough to use a very basic programming language, essentially anything you have seen in the 1980s, BASIC or Pascal, to script the movements of those robots. There's really no interaction between the environment and the robot in traditional industrial robotics. And that's awesome, right? These are great machines. They solve all their problems by being predictable and precise, and there's nothing wrong with that. But if you encounter one of these, a cable or anything that is soft or wobbly or fiddly in some form or moves about as you're handling it as a robot, you were out of your depth in classic industrial robotics. And what we do is essentially give the robots to deal with these types of problems. So the technology allows you to create skills for industrial robots that would be impossible or at least very hard, and you need a very high skilled person to create them. And for us, it's essentially something that anybody, you and me, or anybody you meet on the street, could teach the robot to do as a matter of a couple hours, two afternoons. And then after you've done the training, after you've showed the robot how a good movement looks for whatever you want it to do, then the robot knows how to perform that task and react to the environment in a systematic form and in a clever form. And this is where I am going to pick up the hand-eye coordination metaphor again. So if you imagine a human plugging in a cable into a socket, what we do is not determine exactly where in space the socket is and plan an approach. How do we orient our hand towards the socket, and then we make a very precise linear movement towards the socket. And then if our pose estimation for the socket was right, then it will fit by the millimeter and everything will be fine. What we do is we just move those two things towards each other, and we make a sequence of very small, very fast corrections as we approach. We coordinate the movement of our hand to what our eyes see. And the technology essentially gives a robot the ability to learn precisely that. The way the learning works is you literally touch the robot, you grab it by the wrist, and you guide the robot through the movement as you would guide a human worker when you show them a complex tactile movement for the first time. And you repeat that for a couple hundred times. Sounds like a lot. In reality, this gets done in 2 or 3 hours. And then typically there's a second or third iteration where you do that again until the robot really gets it and becomes precise in generalizing overall the demonstrations you've given. What you get from this is fully sensor-driven, closed-loop, camera-driven, real-time movements. So you can, the robot will approach when it plugs in a socket pretty much like a human would, approaching it, going a bit to the side and seeing with the camera, okay, that's too far right, comes back and makes a very confident, very natural-looking, very organic-looking plugging-in movement as a human would make it. So so what's behind there? What is the technology that has been that's on sale from Micropsi Industries? Is essentially a full stack that allows you to do 20 or 30 hertz real-time control from cameras in a closed-loop fashion. So all of this is ours, has been developed here, and allows you to generate skills for industrial robots very easily without a single line of programming. All you need to do is buy the robot, buy our kit, put up the camera, make sure the cameras see what they need to see to solve the problem, And then you guide the robot through the movements, send the data off to the cloud for training. It comes back, gets installed on the robot. The robot knows how to make the movement. Then you can cut the connection to the internet, so you don't need to be connected all the time to the cloud. Just for the training, you need to do that. And then essentially you do the rest of the automation solution that you want to do. Integrate this into your wider program of how material flows through your factory. And as a result, you just automated something that previously only a human could have done. And normally I show a video that shows that in action. So what is the actual product? What do you buy from us? We don't make robots. We're a software company. You assume you're a factory and you want to automate a workplace that's so far been manned by a human or a couple of humans because they work in shifts and perhaps the rest. So what you would buy is a robot. All the peripherals that you need. This might be a gripper or anything that you need for handling the materials you want to handle. Then you buy the Micropsi Industries Mirai control box, which is a physical box that you put on top of the controller of the robot, and then you connect it. And then on the box there is a tablet app that you can install on your Android tablet, and this tablet app will allow you to train the robot, guide you through the training process. What you also get is cameras and the force torque sensor. Sometimes we provide them, sometimes you buy them separately, that allow you to do that learning, and these components stay in place when the robot operates. So the robot can feel when it hits something, and the robot can see as it moves through the scene. And when all of this is connected, you essentially take your tablet app, do the setup, guide the robot, and after 2 days, without any programming, you have a way of making the movement that so far the human made, without and can integrate this into your wider automation solution. So here's just a couple of platforms that we support. The key ones are, we today work with robots by ABB and Universal Robots. We usually work with OptForce for sensors, and cameras. It doesn't even matter because these are supplied by us. All of them we were founded in late 2014. We're now slightly outdated. 17 people in R&D. Still, most of them R&D focused. Our sales office in New York has just opened last month, so people in the US can come get a demo, meet the people, and get an impression of how the technology works. And we can also now start to set up evaluations. So typically, when people want to automate something, they're not just buying this because I tell them this works. They say, I want to have a go at this. Let's try it. and they either send something in, or we come and try, can our product and the robot actually solve the problem that this person is after, and if that works, we put it into production and make it work. So that's all I have for my little speech.
Thank you very much, Ronnie. That was a very interesting presentation, a very nice graphics, I must say, graphic design level graphics. I've got a few questions. First of all, I wanted to understand exactly what I'm dealing with in terms of your solution. You say you're a software company, but you're actually supplying a box, a controller.
Yes.
Is that correct?
Yes, that is correct. And how do we reconcile that?
Yes. Well, it's not a complex issue, but it's just interesting. I wanted to make that clear. That's all.
Yeah. I mean, the magic of what we do is in the software. The control box just contains a couple of hardware components that we need to be able to do that. And this is not a secret. This is GPUs by NVIDIA. These robots are driven by neural networks, and you need the hardware to just compute the forward passes for neural networks. So we need to bring a GPU, and we also give you a box when you're buying from us, so just nobody has to worry about operating system versions, and it just gives us a stable platform that we can run this from, because we're doing real-time control here. It sort of matters what else is on that computer where the software runs.
Now that box, I'm not a computer expert or expert of anything, but I just want to understand. So the signal, the data that the camera collects goes into the box and then is transmitted to the robotic arm for it to make the movements. Is that?
Yes, that is correct.
Terms? Okay.
Yes, 20 or 30 times a second, we read the cameras, crunch the numbers, do the forward passes of the neural networks, and decide how to move the robotic arm. Yes.
The bit that I wanted to ask, though, is where does the cloud fit in again? So does any of the data from the camera go to the cloud, or does it come? You said closed loop. That means that it doesn't go to the cloud. Is that right?
Exactly. For training, so there's two phases. There's a training phase where the robot doesn't know how to move, and we collect the data, send the data off to the cloud, create what we call a policy or a skill. This gets sent back to the robot and installed there, and from then on, it will be autonomous, know how to move, and doesn't need the cloud to actually perform and produce. So the cloud aspect is, we need to do the actual machine learning here, and doing that on the box that we deliver to customer makes no sense, because that requires a big GPU, some proper powerful hardware to do all the number crunching. And then 99.9% of the time, this big GPU wouldn't do anything, because it just sits around and does the boring forward passes, which are much easier to compute. What we do is we send the data to the cloud for training, and then a very small policy that is completely self-contained and knows how to move the robot based on camera images comes back and gets installed. And then you can cut the connection to the internet if you want. You don't need the cloud at all to operate your factory.
I see. It's very interesting that movement in 3D space creates so much data that a GPU, a computer like the one you're supplying, would not be able to handle a lot of the learning phase of the robot's training. I mean, I'm not saying that is true, but I'm just talking about the general fact that movement in 3D space, rather than, as opposed to calculating mathematical algebra and things like that, cerebral tasks. In other words, if a human was to do some sums, calculations, they would not be generating as much data as if they got up and walked around for a minute or two. You see my point?
Yeah, I have. Yeah, I see your point, and I have two things to say to that. The first one is, I'm joking here, but have you ever tried to rotate just a box, any box in your head around two axes, and can you describe the trajectory that any of the edges takes? It's surprisingly hard.
Well,
surprisingly hard. Okay, joking aside, I can't do it. Joking aside, no, of course, movement in 3D does not generate much data. This is just 6 parameters, 3 spatial dimensions, where are you, and 3 rotational, three orientations around 3 axes. Sometimes you do 4 numbers because you do quaternions, but it's something between 6 and 7 numbers that describe where your robot is in space and how it's oriented. However, the camera data is a different matter. What we do is we train a robot to react to camera images with the right movement, which means the training system needs to see the camera data and then infer how, given that visual information, the right movement would look like. And this generalization from the various demonstrations that humans give to the robot, where the cameras are recording, to a point where you get this down to if you can imagine this like a very complex set of rules of when this pixel is red, then there's a slight tendency to go to the left. Nobody does that as a set of rules. It's a neural network, but it's essentially how it works. So you need to send all the vision data that we record during training to the cloud, and then the actual training, the generalization over all the trajectories and all the movement we've seen is not an easy task. That is the deep learning part, and that is where you need to, if you want to do it quickly, and we have somebody waiting, somebody just did a bunch of demonstrations, so you don't want this to take a week, so you need a big GPU to essentially correlate the right movements to the right images, and that's what we need what we need the big GPUs for.
It's a very interesting area, partly because I've realized that there are a lot of challenges in this area, not least of which is the grippers, the actual hand effectors. What you've talked about so far makes me think that it's mostly a question of orientation of the arm and positioning and so on. The gripper part, what the gripper does, we haven't really talked about that. So I wanted to ask you specifically, how much of a task or component of, how much data or whatever does that part take? And would it matter if you had more sophisticated end effectors? So at the moment, the one I saw in the picture,
yes.
You had two finger gripper basically. But talking to someone else who I was asking, in my own simplistic way, why don't roboticists develop hands that look more like human hands? And he basically said that somebody did try, and there are people who are trying it, but it is just so complicated. It just generates, I don't think he said generates a lot of data, but he just said it's really complicated. And the reason I ask, of course, is because there are lots of objects which have very different textures and sizes and shapes and things like that, all of which becomes a huge mountain of computing problems. So I don't know your comments on any of that. I'd appreciate.
Let me try to be systematic about that. Yeah, it is true that in most of the demos we do, we just use very simple two-finger grippers. Simply because there's sort of a sweet spot for these things right now for applications that so far couldn't be automated with robots, that are now opening up due to our product, essentially AI entering the scene. And there were so many things that could be done with two-finger grippers that couldn't be done because of software reasons so far. That's what everybody is looking at right now. And then beyond that, of course, there's another whole space that would open up if just the end effectors would be a bit more sophisticated. So indeed, right, plugging in cables, you can do that with 2 parallel fingers. Picking lots of things, you can do that. We also work with customers who don't do grippers at all, who have custom manufacturers who put on glue or do some grinding. Essentially, we as a company or our product solves a positioning problem, and we don't care much what we're positioning, whether it's a cable in a gripper or a glue gun, or we're not so interested. We're not trying to learn the actual end effecting. Usually, there's polishing is a different matter, but typically. Most of our applications are about fine positioning a robotic end effector, and we don't care much what it is. Now, beyond two-finger grippers, there is, of course, a large space of very fancy end effectors that have been developed over the last couple of years. There's very good robotic hands with, I think, around 20 degrees of freedom. They look like human hands in many cases. There's one by a German company called Schunk. There's one by a British company called Shadow Robotics, and then a bunch of other people also have them. They're awesome, and our algorithms, if we had a way to teach how they should move, could completely learn to control them. It's just for industrial applications, so far, this market is very narrow for the very simple reason that these hands are, I think a shadow hand is still north of 70,000 pounds or so. So these are, indeed very complicated and very expensive, and more often than not, slightly fragile, at least compared to a, very basic two-finger gripper, which is essentially two slabs of metal and some gears. So we don't really see the applications for these things on a large scale on a short term. We're fully ready to operate them. This is just additional output dimensions, and we could perfectly learn that. We've even talked to the Shadow guys at some point about just doing the demo together. But then we all need to meet money, and this is probably not something that will happen next year. And then the last thing to be said about this is outside things that end effectors have tried to mimic the human hand. There's a lot of very interesting things that are now happening. There's soft robotics, which have these tentacles that are very good at gripping irregularly shaped objects without understanding much of the object. Just the gripper itself is sort of compliant and soft and smart enough to just wrap around this. It looks, anybody who hasn't seen it, I recommend this. It's cool. It's quite tentacly. And then there's from, I think, Festo, there is something that sucks the object you want to grip into a balloon. So there's many people do very interesting concepts and products around end effectors, even standard ones that don't look like human hands. And cycling this back to our product, we don't care much. We position whatever you mount to your robot. As long as a camera sees it and you can learn where it ought to be, we will position it. And that's cool.
Okay, thank you very much for your insight there. And I do realize that it's kind of slightly not beyond, but your priority is the camera and hand-eye coordination, or the equivalent thereof. That's your main concern. So I'll ask you what markets and customers your solution currently appeals to. I know you gave me a list of partners you're currently working with, or rather platforms, robot makers, camera companies whose equipment your solution is compatible with. But what about the market, the end result, as it were? What kind of things you can tell me about that? Can you tell me about that?
Yeah. So these are typically mid-sized companies, so between 500 and a billion in revenues, which is sort of the sweet spot for automation right now. The really big guys are tougher to tackle. So usually we talk to the mid-sized companies. They have lots of problems that so far were solved by humans, and they want to start to automate with robots. And these are typically, either in electronics manufacturing or in, just electrical household appliances or tools. We have customers in, this being Germany, we have customers who make machines, and metal part handling is a big part of the existing evaluations that we're going through. So these are, not your first tiers, not the BMWs of this world, but sort of the suppliers to those, and the suppliers to those suppliers that we typically work with today.
And what kind of tasks can you give me an example of? I know in your pictures you showed the robot plugging in an Ethernet cable, but is there any other example you can give of what your system?
Yeah, so Ethernet cables are,
I know you can
actually real,
anything, but what are the examples you can?
No, I can. Yeah, Ethernet plugging is actually real, and we use Ethernet just as something most people are familiar with. We should do USB at some point, so it can really learn to insert anything, anything that's a cable. This system can learn how to insert. That's so all types of cable plugging and insertion of plastic parts into metal holes or the other way around works with our system. We're also doing things like positioning probes. So in testing, sometimes you need to position a certain type of probe, something that picks up molecules that are evaporating somewhere. You measure if something is escaping, and you need to get very close. And your target isn't always in the same place, or looks slightly differently. And then you need to position the probe towards that target. That's something that we've very successfully evaluated. Applications, like gluing things, that's something we're starting to look into now. We don't see why it wouldn't work. Where essentially you need to find a irregularly shaped and irregularly placed position on a piece of work, and you want to apply glue to a visually distinctive place on that piece of work. So that is something that we're confident. And then we also do picking work, where essentially have a crate full of metal parts, and they all look the same, and we are being tasked with finding a right place to open or close the gripper to pick them up and move them onto a conveyor belt. Which is something, there are solutions out there. Lots of people are tackling this. Typically, these customers are interested in our solution because it doesn't require any programming or any fancy kit. Essentially, you mount a camera to the robot's wrist, start training, and then after 2 days, it knows how to pick these objects from a crate.
All right, thank you very much. And I think the last question I'll ask you is one that somebody else was indicating. Everybody seems very interested in the market that's even smaller than the one that you're going for. I know you said mid sort of level, which is great, and I hope it works out for you. But these robots are relatively cheap and affordable by even smaller, maybe family-owned, single sort of family-owned small business. And they can, but then it becomes a question of how do you figure out which part of your process you can automate, and then is it cost effective, and so on. I was just wondering what kind of I don't know, knowledge or information you have, if not experience of smaller businesses, because I'm mindful of the fact that a lot of businesses, a large percent of businesses, are small family-run operations, like much smaller than your 500 million to a billion sort of range you're talking about. Yeah. But what do you see the potential for technologies like this in much smaller operations?
So I mean, we do, from our market research, we do share the enthusiasm about SMEs that are actually SMEs, that are actually small. We just discount it a bit and think it will take a while before this really takes off. There are some indications that it's happening. If you look at the numbers that Universal Robots publishes, they're quite good. And I think a share, we don't know the absolute numbers, but I think a share of these actually goes to fairly small outfits that buy a robot to do some packaging or just some pick and place, something that's very simple, and that with this machine for the first time is actually accessible to them because of the price of the machine, but more importantly, because it's easy to program and because there's an easy to integrate ecosystem of just equipment that goes with it that is pre-integrated with the robot. So a couple years back, when you wanted to do an automation solution with a robot, you had to ring somebody up, and this would be a very expensive project that would run for a long time. Now with Universal Robots, you're at a point where you're almost at a point where you can order this from a web shop, and then there's just a list of things that are pre-integrated with this. There's just a force torque sensor that will work out of the box with this robot, and the software will work together. There's a gripper, and there's actually a choice of grippers that will work with it. And then, even for a technically savvy layperson who hasn't done any robotics, putting together a system that, I don't know, moves some objects from left to the right between two conveyor belts if they're always in the same position is actually quite easy to do. There's still some market education to do, and also there might something happen to the prices of these machines before this really becomes as big as everybody anticipates, and certainly the market research firms are anticipating. But we do see this happen, and everybody is hoping for the moment where you don't need to call a specialized engineering firm to build a single robot automation solution that maybe runs for 3 months, and then you repurpose it and do something else with it. That's sort of what everybody goes for. And I mean, our system fits in nicely. We will be, like the gripping, Universal Robot sells you an arm, and the gripper component sells you a hand, and the force torque sensor company sells you some nerves to sense your environment, and we're supplying the eyes and the brain for applications that need that, where you need to make a movement where the clues for making the right movements can only be picked up visually, and there isn't an easy way to just write a program that would do that, that would perform that action. So long answer. I think the summary is, yeah, this is attractive. I wouldn't bet my business on it happening next year right now, which is why we like to work with the bigger guys who know a thing or two about automation and have done it for a while and have some experience on sometimes just dealing with metal parts of it, the pure scaffolding of it.
Okay, thank you very much. One last, sorry, I forgot. I think it's important to ask: do you only provide custom solutions, or is it something that people can just buy and implement themselves without really needing you to help them implement it directly?
Absolutely. Right now, and this is a pure product maturity thing. So this month, if you call me and say I have a problem I want to automate, I will sell you a box, but we will come by and look at it and help you set it up properly. 6 months down the line, that won't be necessary. Right now, this is just making sure that our customers actually have some form of success with deploying this. In the end, all the system is designed in a way that doesn't require us to be around to work. And we're not, by the way, we're not doing solutions. We're selling. I mean, we explain the solution. We explain to people, how an automation project for something like this works. We have people who have done it in automotive for a long time, so we're quite good at that. But in the end, the product that we're selling, you buy that as an additional piece of kit to your robot, and you can generate the skills that you need completely on your own. The tablet app has been designed with just some average person who hasn't done any robotics or any AI in their past, and they can create those skills. So while we're not quite there yet, mostly because we just like to see customers interacting with the product, we like to be part of those deployments. But the way the product is designed, we'll be able to do that with without any interaction with us, essentially.
Okay, thank you very much.
Send us an email at sales@roboticsandautomationnews.com to register for one of our many upcoming webinars. And if you'd like us to host your webinar, we have a range of options, including long-term lead generation packages and marketing campaigns. We look forward to hearing from you soon.